Okay, hello, good morning. I did a lot of reflecting yesterday um, about how we've been implementing this state machine, and actually, it's hard to explain. Like for me, going into new concepts, I always have to kind of find my way to think about it, and I always try to make things simpler, because a lot of concepts are unnecessarily complex, especially in terms of like getting most of the value out of things. So like 80% could have like a very simple API, but because of the last 20%, the API becomes very complex, for example. But one thing I think we did wrong here is that we are explicitly trying to transition these state machines. So we are not like saying, I want to, how should I say this? Like it's very direct. You're saying, I want to move into this state and I'm providing this data to move into that state. And then we describe like, as we can see here, then we describe like what are the valid transitions, which makes sense. It does make sense. But then there is this other level to this API, which is not explicitly transitioning, but having implicit transitions, which means that instead of describing or explicitly trying to transition into a specific state, you just say, okay, I have this piece of information. I'm passing this like an event into the machine. And then the machine knows how to deal with that event. It maps basically to a method where you are able to update the state of the machine, and then as part of that update you also transition into a specific transition state. So instead of talking about this, I can show you the change I made. So the way this works now is that you still have the states, but I don't have an explicit concept of base state. You just describe your states like this, and then you can add the base state. So basically one of these states and this base state. And then we have something called events. And this is what XState does as well. So this is what you actually do when you work in your actions. You try to set adding, for example. So that's the thing, like most of these events are related to updating state, but some of them maps directly to trying to transition into a state. So in this case, we want to go into the adding transition state, but we don't need any data to do that. So we basically just expose an event that allows us to transition directly into that thing. But most things are related to, okay, you pass some data along with it, and then you do the transition. So what this does is, if we take a look here, so instead of having this object of states and what other states can you move into based on the current state, which is very explicit, like declaratively, it's declarative. It's very kind of nice to see how the machine operates, but at the same time we're putting kind of the like we're limiting how you can change the state, and we had some serious issues with typing and stuff to kind of merge these two concepts. So the way this works now is that if I want to set adding, I describe that as a function. And this function takes the current state, and then optionally, if it had some data, I will get that. But set adding doesn't have any data. And then I'm able to do whatever I need to do here. So instead of describing adding, so let's say instead of describing like in the valid state, you're allowed to set description, move to adding, move to this, move to that. You basically just say, okay, whenever I receive this event, if the current state is valid, then we'll move to adding. So you describe it with code instead. And what this solves is that we don't have to create this mapping of, okay, I want to move to a specific transition. We have to ensure that you give the correct state. This is rather something you ensure by implementing these functions. So in this case, we want to set the description, and we pass in a description here. As you can see, set description, data is a string. And then we set that description, and based on having a description or not, we move into the valid or the invalid transition state. And then for update weekdays, we don't check anything. Like what is our current state, because we don't care about that. We have said that you should be able to update active weekdays at any state of the machine or transition state. So what we do here, this is where we actually update the thing. We expect to get a weekday. And then it's the same for set date and setting an error. So we could check here, for example, if state current equals adding, for example, that's when we actually allow you to set an error. So the point is that you programmatically implement all the guards and everything, like the state changes and the guards. It's one concept. So the signature of this is like, this is an event type. You have a callback for that event, which gives you access to the state of the machine and whatever payload was passed on the event. And then you implement the guarding and you return any state you want to transition to. If you don't return anything, it stays in the same transition state. So that's the way it works. Yes, and what we're doing now is that we're putting a lot more logic into the machine. So you can imagine if you were to implement a machine, you would actually implement all of this. What is the public API of this machine? This is the public API of the machine. And then you decide as the implementer of the machine, how should it deal with this public API? While previously we were lower level, we kind of moved down to explicitly transitioning the machine and setting the state. But now you're not setting the state anymore. This is something the machine does based on the events you pass into it. And what this does, yeah, I think we just need to move along and do some refactoring. But yeah, I do think this makes a lot more sense. And it should clean up our actions a bunch, because now we're just triggering these things, right? We're not having any logic related to setting state at all, really. So that's pretty nice. Yes, so let's look at how this would be with our app. So first of all, didn't we have... Yeah, we had some base state here as well. So we're going to move this down to... So we have our states. So we put parentheses around it and then we add base state there. So this is how this, I think this is a good convention that you kind of, first you explain the explicit transition states and then you add the base state at the end. And then we have a type called events. So we have to do quite a bit of reasoning here. So let's see, this should be events and events. And what do we actually need there? So we kind of have to go through and look at what we need. So I know we need to be able to transition to the home page, or we could have like an event that allows you to like change page, for example. And then the data would be yeah, I don't have these different pages in oh yeah, so we don't need these anymore. Well, I can keep them for now. We'll refactor that. So yeah, I'll just repeat them. So it's either home or add backlog item or plan next week, or edit current week. So those are the different pages. Or we might have an event. So the logic of changing the page, it requires a bit of logic. So that's kind of the negative thing about this, is that here we kind of just describe the transitions declaratively, and it will just deal with that. But now we're actually implementing. We are actually like implementing how it should deal with the transitions. But it's more powerful because you can have like way more dynamic, a way more dynamic way of expression than doing it declaratively like this. Because you do want this guarding logic as well. So you kind of, instead of splitting it up into, okay, these are the allowed transitions, these are the guards for the exceptions, these are the methods for updating the state. You kind of merge that into one concept, which is what I've been talking about. I'd like to try to simplify the API. Anyways, so this is transitioning between pages, and then we had update backlog. Data here would be backlog items, and then we have type update days, and the data here would be days by, yeah, I'm not actually sure what we're passing there, but let's say it's that one. Cool. So I think this is basically what we need, and I could have moved these two things into the same types, so we could kind of reuse this, but I'm not going to do that. Like I could have used an enum, for example. Anyways, so it tells me to implement change page here. So we have our state and we have our page. Now, what we need to do now, we should probably use a switch here where we say if we are trying to switch to home, then we return home. So we should always be allowed to we should always be allowed to move to the home page. It doesn't matter which page we're on, we can always move to home. And then we have add backlog item. And yeah, I'm not sure if a switch statement is the best way to express this, but let's try it. And then if the state is home, yeah, well, we can just do this. So if we are home, we should move to add backlog item. If not, we don't, like if it's falsy, it won't do the transition. So this will be like false and it returns false, and that's perfectly okay. And then if we want to move to edit current week, we basically have the same logic. So if we are home, we can move to edit current week. Yeah, okay, so maybe we can just make an exception here. So if the page equals home, we return home. If it's not home, we check return state.current equals home, and then we return to the, then we move to the page. That's basically, this is how we can express. Oh yeah, sorry, I didn't. Let's see, if state.current equals home, return page. Shouldn't this work? Ah, TypeScript yells at me, I guess. We have to return something. Return, does that work? Undefined. Ah, this sucks. Was it? Oh, sorry, it's, oh, sorry, it's just missing the other. other things, I guess. Anyways, so this is how our application works. We have a home page, and then we have these other pages. And the only way to move into these other pages is to be on the home page. But if we are on any of the other pages and we want to move home, we can just move home. So whenever we want to move home, we just we move to home. If it's any other page and we are home, we are allowed to move there. And this is what's kind of nice about this as well, is that you can decide to throw errors here if you want to do that. And that's been kind of a split opinion, is when you try to move into to do like invalid stuff, should you throw an error or should you ignore it? At least here you can decide how you want to deal with it. What other things do we have? Update backlog. Backlog. And again, we don't care what state we are in. So we are just going to assign state backlog with backlog. Maybe I can call it update. And update days. And this is the same thing. Days. Update. We want to assign state.days with update. Right? So here we are more effectively describing the state updates and if it causes any transitions. So basically we reduced a lot of stuff here down to this thing. This is basically the only transition stuff it does. It's when you're changing the page. Everything else is related to state changes. And we're controlling this from inside the machine now, which I got this comment from Ronnie, who's been following closely, and we've been discussing a lot of state machines. And I think he's been a little bit, not frustrated, but like, what the hell are you doing? You're doing so much logic in your actions. This should be inside the machine. And I think you're perfectly right, Ronnie. And again, this is not, like we could be more declarative here. We could have this split. These are the allowed transitions. These are the guards. This is the state changes. We could have those as 3 different concepts, but I really want to explore having one single concept for them, which is basically just this callback. Cool. So that's basically it for this one. So let's look at our auth. Oh, sorry. One thing we wanted to remove is we don't need these ones anymore. Cool. And then we have our auth. So we had a little bit of base state here. Let's move that. Let's put parentheses. By the way, I have to go after half an hour today because kindergarten is closed and my girlfriend, who's like insanely pregnant, is doing like a checkup thing. And our daughter is like 4 years old, so I can't like just put it. Well, I could put her in front of like TV shows, but it doesn't feel right. And let's see, an event. And then, okay, so what do we want to do here? We want to, what should we call these? So we could actually call them authenticate. So if we are authenticating, we want to pass in the user. Data is the user. Yeah, so this is interesting. So when we authenticate, I think we want the user and the profile. But we don't need the app machine. Because that's something we can trigger from the inside. Or do we want to do that from the outside? That's a good question. No, we should do it from the inside, I think. Anyways, it does have an app machine here, but we only pass in a user and the user's profile. So if I wanted to pass in the app machine from the outside, I would just add it here to authenticate. But the app machine doesn't have any, like, it doesn't need any information from the outside to fire up. So we'll do it from inside this machine. Yes, and then we could have something called an authenticate. And then the data here would be a string, because that will give us the reason. And then we could say invalid n. I think that's enough. We just say invalid n. Yes, and then we have this authenticating transition state, but that's not part of that. That's nothing you kind of control from the outside. Well, I guess you do. There's another thing here, which would be, oops, type login. Yeah, so this is interesting as well. Yeah, so I see one thing that's happening here, and that is we're also controlling the effects. We're controlling the effects from the outside now. So in a typical state machine, you would have effects also defined like on the machine itself. And then you, based on the events coming into the machine, you would trigger those effects. But the problem with doing that is that effects are asynchronous, and I think it would be healthy to find a good way to separate effects from the machine itself. So the machine is only about state changes, synchronous state changes. It simplifies. But the question is like, how would we do this login thing? So for example, I click a button to log in. And then, so I send an event to the machine that I want to log in. And then if that's okay, I will start the login process from the outside. Yeah, I'm wondering, like, I think it's the terms. I'm a little bit hesitant on how to express the terms here. So first of all, we are kind of like idle. We don't have that state now, but let's imagine we're idle. And then we click login. So the event is really login. And then blah, 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 blah. It starts logging in, and the machine transitions to authenticating. And then when we are logged in, authenticate. It's probably not the right term. We basically, well, you move, authenticate, and then you move. Like, when do you authenticate? Like, I would suggest when you click the login button, that's when you start to authenticate. Yeah, so this is more like resolve. Maybe I shouldn't use these terms. I should use login, like resolve login, for example. And then reject login. Like that, I think that's more how you would think about this. So these are, yeah, I guess you have to decide, should these be like, what do you call it? Imperative terms. And then these are declarative terms. You understand what I mean? This is where you do something. And this is the result of doing that thing. or like the state of doing that thing, something like that. And then you would have reject env. Yeah, something like that. Let's try that first. And yeah, I think we'll have time to try to implement this. So let's see. First of all, we have our login. So when we try to log in, we have to be in, let's see, state. When are we allowed to log in? We are allowed to log in when we are unauthenticated. So if state current equals unauthenticated, return authenticating. That's when we are allowed to log in. When are we allowed to resolve the login? Then we have a user and a profile. We are allowed to resolve the login if the state is authenticating. And what we want to do, we want to set state. Oh yeah. Yeah, sorry. So when you when we do it like this, as you can see, I don't have either the user or the profile here, even though I kind of said that I have it on authenticated. But the reason is in this state, we are actually authenticating, right? Where we don't have the user and the profile. And this is the tricky thing about the typing, is when you have the logic like this, and this is the same in X state, where you you move from a state where you don't have the data to the state where you actually have the data. So how do you then dynamically express, like, we might set the data or we might not set the data? And the way you do that is you basically have to do this. So we might have a profile there and we might have a user there, right? And then we could be very explicit and say we definitely do not have a user here and we definitely do not have a profile here. We could say that, but I do not see that as like a necessary thing, unless you actually explicitly remove the user and the profile when you move into an authenticated. That could be a thing. Anyways, so now we might have a profile, and state.user is the user, and then we'll return authenticated, right? And then we have reject login, state, what did we get? Reason. Let's just write this now. And we want to reject the login if our current state is well, it could be, yeah, this is a good question, because we might be yeah. So this would be more like, yeah, how should we logged out? Like, that's the thing. This is kind of like what happened on the outside. You actually were unauthenticated. And maybe that's perfectly okay. Maybe that's a good thing. Let's try. I want to try that, because I don't think it actually matters. So you kind of have your private, this is your private state, right? Your private protected state. And then this is your public API. And it's based on events. And these events are, you can perfectly describe them like this. And if it has the same name as the transition state, I don't think that matters. I think it just makes it simpler, because in this case with unauthenticated, we just tell the machine, okay, from the outside world now we became unauthenticated, which is, yeah, wow, this is so tricky. Because now we're conceptually moving towards this thing where, but shouldn't the machine just handle everything? Shouldn't that hold all the logic for the effect of, so it would internally move between these states without you having to implement it from the outside? Yeah, maybe that's the problem here. Like, we're trying to implement state machines as only state, not effects. But if you're going to, but again, like, this should work, because imagine like you create a state machine for something like mouse drag and drop, for example. All the events are coming from the outside. And this is what's happening here as well. All the events are coming from the outside. The scope of the machine is to manage state, not to think about the outside world. And that's what makes them so reusable as well. Because I might be using Firebase, for example, for authentication. And you might be using some other system, but we can use the same authentication machine because we're just firing events from the outside into the machine. Yeah, sorry, I'm like, I have to find a, like, I have to fit the pieces in my head to properly understand this. So let's authenticate it. Let's call it authenticated, and then unauthenticated, unauthenticated, and then state current. If we are authenticated or we are authenticating, that's when we are allowed to. And then we have to, again, we have a reason here. And then we could say like error, it's a string, but we pass in a reason here. So we say state.error equals reason. And then we return unauthenticated. Didn't we? Oh, sorry. No. Why is it complaining? Why are you complaining? Oh, type unknown. Sorry. Unauthenticated. Why are you complaining? Okay, I probably have some syntax error here or something. Did you mean? Oh, sorry. There we go. And then we have invalid env. Okay, now that's it. Invalid env. This can happen at any point, really. Yeah, we didn't care about that. Invalid env. And we can make that even shorter. Yes, anyways, so I'm not sure, like, should the type of events, some type of events should be different than the actual transition states, because they, for example, set description. Makes a ton of sense. But some of these events are very tied to the transition state you're trying to move to. So for example, we're authenticating. This is what's happening from the outside. And it just happens to be that this machine uses the same transition state for that. And then we have an authenticated event from the outside, passing in a user and a profile. And then we guard that. Okay, this can only manipulate the machine if we are actually authenticating at this point in time. So we set the data we want, and then we return that we're moving into authenticated. Yeah, kommer. And then we have unauthenticated, happens from the outside. We guard it. This can only be handled by the machine if we are already authenticated or if we are authenticating. We set an error, which is the reason for being unauthenticated, and then we return that we actually moved to that state. And then we might get an invalid environment from the outside, and that transitions the state into invalid environment. So I think it makes sense. Like if you want to, for example, do we have, so here, set adding, for example, we don't have to say set adding. We can rather say adding, because that's what's happening from the outside. We are adding something, and it maps directly to a transition state. But then we have these other things, which doesn't map directly to a transition state. Something happened from the outside, and it happens to sometimes move into a transition state, sometimes it doesn't. Yes. Cool. Yes. I think that's it for now. We're going to continue refactoring this tomorrow, and then we'll see how this actually works out. But yeah, I just have to get to this mental image of how this should work. But as I said, I really like this separation of, you have this generic state machine that only cares about its state, right? It doesn't care about the outside world. That's up to you. Hæ? Ja, greit, jeg kommer nå. Sorry. So you have to provide the data and the events happening in the world and provide it to the machine. And then the machine is like a world interpreter, which is able to kind of, in a controlled way, interpret what's happening in the outside world. Something like that. Anyways, as you probably understand, I have to go. But we'll dive more into this tomorrow, and I'll see if I can kind of conceptualize this a little bit better. Yeah. Thanks for following along, and we'll talk more tomorrow morning. Bye for now.